We would like to warmly welcome you to this ForestBioFacts event presented by Finnish Forest Products Engineers Association, PI. It's important to us to comply with the European Union competition law. We should keep this checklist in mind at all PI and ForestBioFacts events. So, let's honor the competition law in our comments and conversations. The world is digitalizing at an accelerating pace, which creates a need for new learning methods. The forest industry has also experienced significant changes within the last decade. In addition to traditional pulp and paper manufacturing, many new forest-based products and end uses have emerged. ForestBioFacts is the world's largest digital learning environment focused on forest-based bioeconomy. The information is suitable for all learning levels, from students of the field to experienced professionals and researchers. ForestBioFacts has 16 themes covering the whole value chain of forest-based bioeconomy. Over 150 experts working at universities and in the industry have participated in making the content. Save time and find the information you need within minutes. During the event, we would like to encourage you to write down your thoughts, comments, and questions in the chat window. We recommend doing this during each presentation so that we can go through them after the presentations. Welcome aboard!
Good morning and good afternoon, everyone, and welcome to our webinar. Thank you for joining us today. Today's webinar topic is Who Says You Can't Make Money from Lignin? This webinar is organized in collaboration with the ForestBioFacts, Finnish Forest Products Engineers Association, and TAPPI. My name is Veera Hallikainen. I'm the Development Manager at Finnish Forest Product Engineers Association, and I will be co-hosting and co-moderating this webinar together with my colleague from TAPPI, Jan Borilieri. If you want to introduce yourself, Jan.
Good morning from California. I'm Jan Borilieri, and I'm the editor for Paper 360 magazine. Welcome.
We have a very busy schedule and tight program today, which will feature presentations and explaining kind of the role of lignin in our journey towards sustainable materials and how lignin can generate new value streams. We start our program with a joint presentation from Lari Vähäsalo, co-founder and R&D director at CH Bioforce, and Vesa Kukkamo, CEO from ACA Systems. Then we move on to Elina Lohiniva, director business development lignin at Andritz. We have Victor Odenbrink, sales director bioproducts from Södra, and then we end with Chris Lütgen, Executive Director, Alliance for Pulp and Paper Technology Innovation, and Professor of the Practice and Associate Director at Georgia Institute of Technology. But before we kick off our program, just a reminder or an encouragement to ask questions through the chat window. We will be taking these after each presentation. We have a couple of minutes reserved, and I'm sure that if you don't get your question answered, you can contact all of our speakers afterwards for that. This webinar will be recorded, and the recording will be shared through the ForestBioFacts digital learning environment in a couple of days, and also on TAPPI's website, where there are plenty of other webinar recordings available as well. But now, without further ado, let me introduce our first speakers, who will give a joint presentation on the potential of lignin as a sustainable coating additive. We have Lari Vähäsalo, the co-founder and R&D director at CH Bioforce. Lari has decades of experience in wood and paper chemistry. He's an innovator in biomass fractionation and has developed groundbreaking methods for extracting lignin without sulfur. He's joined by Vesa Kukkamo, CEO of ACA Systems. Vesa is a seasoned executive in the chemical and paper technology industries, and he's also a guest professor at the Munich University of Applied Sciences. Please, Lari and Vesa, the stage is yours.
Good afternoon, everybody, or morning, wherever in California it is. I'll just start my presentation here, or first of all, I'd like to point out that the story of CH Bioforce actually started already in 2011, or actually earlier than that, as an academic exercise. In any case, what we have developed throughout the years with various research projects and whatnot is to fractionate biomass to its full extent. So what we take is normally we started with wood biomass, but we have slowly but surely moved over to more, let's say, side stream, potentially workable biomasses. We invented a method that could extract out hemicelluloses extremely efficiently in pure form, and followed by that we stumbled upon lignin without being able or needed to be extracted with sulfur containing products, and this has turned out to be an extremely interesting product for us. We have scaled up our production to our pilot scale, which is a couple of 3,000 liters reactor that we have here in Finland at the moment that we're scaling up to industrial scale. In any case, what we do really is we extract out the hemicelluloses in their polymeric and most natural form, and in pure form with only water. So this is pressurized hot water, which is in a sense not really inventive if you think about the years and decades before us, but in any case, the methodology in itself has quite many implications for the product quality. But what we are certainly most interested in is the sulfur-free lignin as of its highly efficient product qualities. If we look at the lignin, we have actually deemed it a product name called Lignans, a registered trademark. What we are interested in most applications is its true abilities to give some added value for many products. It's a UV blocker, antioxidant, and antimicrobial agent, and especially in cosmetics and in food packaging, this has caused a lot of roar and interest as of, let's say, shelf life applications. However, when we go to coating and making barriers that contain, let's say, lignin-containing properties and these effects that we want, we need to understand how does this lignans or our lignin affect the barrier formulations, and how do they how will they apply for in real life applications. And this is really where we ended up combining our efforts with ACA Solutions to look at how do coating applications and formulations end up behaving in real life applications. Of course, lignin can be also turned into lignin resins like lignin phenol resins and whatnot applications, but we are really looking at these special properties that we find in this sulfur-free lignin that we can produce.
Okay, hello also from my side, and thank you, Lari, for a nice introduction. Thank you, organizer Vera and others. Very interesting webinar and glad to be part of it. We start with materials and methods, so we wanted to keep this very simple for having a short overview what we have done. So we had a water-based barrier dispersion as a base material. This was a commercial acrylic-based colloidal system. And then we used the CH Bioforce lignin, and we formulated 4 recipes. We just added 5 parts of lignin on 100 parts of barrier, and made up with 2 different temperatures just to check the temperature effect on viscosity properties, and solids content was kept constant. So basically, we just wanted to understand how this lignin will affect the water-based barrier dispersion. When it comes to viscosity measurement, we wanted to understand process-related rheology and viscosity. This is where we are specialized. We are measuring different formulations in high shear conditions that are present in high-speed coating processes. So we want to simulate and create a similar kind of stress that you have in real processes, and use flow channels that are simulating the process effects. And we used this instrument from our AX100 high shear capillary rheometer, and that's the basic setup for the trial. A few words about the instrument. So as I said, we are specialized in process rheology, and we try to understand behavior of different materials in process conditions. How we can do it? We have developed this new capillary viscometer or rheometer, and we are pressurizing the sample with the high pressure method up to 150 bars, and then we are forcing the liquid or coating color through a narrow capillar. In high pressure measurements, we use 0.5 times 50 millimeter capillar, and we can reach shear rates from 200 to 1 million roughly. And this is very relevant for plate coating and film pre-metering. So those metering elements that are having a very narrow gap for coating color to flow and very high speed, there we have extremely high shear rates, and this is responsible for coat weight control, for example. And we have a TAPPI method for that. Then we can also measure low pressure. We reduce the pressure and use a little bit wider capillar, and result in shear rate range of 10,000 to 200,000 roughly. And this is more relevant for sizing and film coating. And finally, we can also select the orifice method, which is nothing else than a very short capillar. With that geometry, we can create accelerating flow, and we can calculate dynamic extensional viscosity. This is also a TAPPI standard, and you can learn from these methods more from there. And this is very relevant for curtain and spray coating, where you have accelerating flow in the process. So now if we look at the results, there are a couple of interesting things to be mentioned. This is the flow curves and the viscosity curves and the shear rates. First of all, the blue lines are barriers, and then the red lines are barriers with lignin. And if we look at this mid shear viscosity, the beginning of the curve, we see immediately that lignin is actually increasing the viscosity, and the viscosity curve is shear thinning. Whereas then in high shear area, we are destroying these kind of crystals or structures that are obviously formed by lignin, and then we are having in high shear area, we are having a dilatant curve, meaning shear thickening curve, and this is quite typical actually for colloidal systems where we have a very narrow particle size distribution. So that will then contribute a shear thickening behavior, and this is not very optimal for runnability in high speed coating. But we see that actually lignin is reducing this dilatancy in high shear area. So it is affecting in a way first to have a higher viscosity in low or mid shear area, but then reducing the high shear viscosity. And we are now entering into conclusions. We can say that at low shears, the lignin increased slightly the viscosity, and the viscosity curve is pseudoplastic, so shear thinning. and this is likely due to chemical interaction and structural network formation within the dispersion. Whereas at high CRAs, the lignin reduced the dilatancy, and it indicates a kind of a friction dampening effect between the colloidal particles. And so I think this is very interesting finding that we are seeing such a dual effect, a combination of pseudoplasticity at low shear and reduced dilatancy at high shear. It potentially improves the runnability in high-speed coating. This is based on our experiences, so that it enhances the leveling and film formation if we have a shear thinning behavior at low and mid shear, but also when we have a reduced high shear viscosity, we reduce the stress on metering element and minimize flow defects like ripping and misting. And this, in general, this is responsible for coat weight control, and for barrier coating. It's quite important to control the coat weight in a proper way, that you get good profiles and good film forming. Of course, there are a lot of studies to be done in the future, and we plan together with Bioforce to do more studies on formulation optimization, application-specific trials, and then the stability issues for long-term stability and barrier stability. But for this short study, we see already quite interesting effects of lignin as a coating additive, and with that, I think we are ending this presentation and ready for your questions. Thank you.
Excellent. Thank you so much for a presentation that was very clear, showing real commercial value with so much potential. We have some questions. I'm going to start with a very straightforward question. What is the form of the lignin that's added to the barrier formulation? Is it added as a powder, or is it added in the form of nanoparticles?
That's a good question, actually. Our process is actually, we don't involve, unless wanted, drying of the lignin. We use membrane technology to concentrate our lignin and get the alkali and stuff in our process into circulation and chemical recovery through those measures. Our lignin comes as a concentrate at a concentration of, well, in this case it was 25, but we can adjust it to 40 to 50% dry content, which gives us a leverage. It's a so-called sodium salt of lignin.
Okay, very interesting. Another question is, can this be used to produce lignin in kraft mills without extracting the hemicellulose?
Well, certainly it could be. First of all, I'm not sure a kraft mill would require the sulfur if the hemicellulose was removed, but certainly there are many aspects of our process and knowledge of how lignin behaves and what properties are interested in it. We do a lot of research and R&D work with research groups and universities, where we can certainly find ideas of producing these type of phenomena.
Someone has asked if you can elaborate a bit on the crystal formation that you mentioned at high shear rates.
I think it was mentioned more in low mid-shear rate viscosity, where the viscosity was increased via this kind of a structural formation, which is typical when you have a chemical interaction between the colloidal systems. And maybe Larry can comment more on lignin side, what kind of structures it can form.
Just shortly, lignin is extremely versatile in forming all sorts of clusters and stuff like that when the concentration is increased. These are properties that can be utilized in many applications as a behavioral component, a structural or viscosity, let's say, forming or modifying aspects and properties. if you have, and the temperature is extremely important in lignin chemistry in general, but lignin always comes as clusters when it's settled. When you give it some speed, it starts to break down and becomes more fluid and behaves as an emulsifier.
Here's a straightforward question. Does adding lignin solution change the color of clear or transparent coatings?
Certainly.
Could you elaborate a bit?
Of course, depending on the source of lignin, the color might be anything from pale gray or brownish to anything to really dark black. If you take lignin from straw, that's quite dark, really, really dark black. And when you go to more, let's say, wood-based, you can get really, really pale colors.
That's quite interesting. That leads me to an earlier question that someone had asked. Are there any particular challenges in terms of using agricultural biomass instead of wood as the raw material? I mean, you mentioned the color. Are there others?
I see mostly benefits. First of all, at this moment, for example, what we're using is oat husks, and it has to do to a certain extent with the fact that the hemicelluloses we want to provide as dietary fibers. So it's good to have a raw material that is not normally being burnt, but is from the food chain where you have traceability and whatnot. So also the lignin, that's why we have also these Cosmos registry or appliances for cosmetics, because we have traceability and everything in place due to the sourcing. When you go to straw, for example, or other agricultural materials, you have to be aware of the sourcing of the material so that you don't get stones, whatnot, ground. Too high silicate amounts will cause you problems in the process, which you have to deal with. We have all those in place also in our process. We've dealt with Indian rice straw and whatnot, so which has 12% of silicates, and those will really be a, let's say, headache forming component in some cases.
Quite challenging.
Yeah.
Excellent. We have some other questions, but Vera, have we reached our time limit for questions?
No, I think we still have a few minutes.
Okay, great. Let me take a look here. We have a question that's quite interesting. Is it practical to use membrane technology to extract lignin at large scale to substitute or augment the traditional black liquor evaporation?
Absolutely. First of all, I'd like to go first. We worked at least 8 years with sourcing of membranes that actually work. So membrane technology is not just something you go to the shop and take off the shelf. You really need to utilize the ones that work. We've been using our oldest membrane that we're using still is 8 years old. They don't break that fast. Of course, the investment is beginning investment is a bit higher than evaporation, but considering our whole process, how we build it up, when we take out the free sodium hydroxide through membranes and really concentrate the lignin, we get all the lignin and not the salts in the system and in the product. It's water soluble all the way to the customer at 50% consistency, and you can utilize it as such. Of course, it's a bit alkaline, pH 11 approximately, but whatnot. If you do phenol resin, lignin resins, you work at pHs 12.5. So there's a real need for this type of lignin in general.
Now, I'm not sure if you've addressed this directly. The question has come through, how do you extract the lignin? Do you use acid to precipitate the lignin? Can you clarify that a bit? Yeah.
Once we have the hemicelluloses out of the raw material, what we do is we simply add a quite lean amount of alkali, sodium hydroxide, potassium hydroxide, depending on the need, and we simply wash out the lignin. It's a 15-minute process, and then we have the lignin in solution. And what we do after that is we simply concentrate it with nanofiltration, take out the free sodium or potassium hydroxide, feed it back into the system, and take out the concentrated sodium or potassium lignin salt, which is it's a putty, kind of like, I don't know. It's a good something you eat from a yogurt box. It's brown.
Right. Okay. Interesting. The question has come through, do you also do lignosulfonate?
Well, this has nothing to do with lignosulfonate as we're not using sulfur, but you can certainly sulfonate the lignin if you want to.
Okay. But that would be after the process.
Yeah. We
Yeah,
can send it
sure.
out for somebody to sulfonate it if you want.
I think now we have to start
Okay.
moving on to the next presentation.
Some quite
What was
excellent
there?
questions. Thank you to our attendees for those.
Yes, absolutely. Thank you for the lively discussion and multitude of questions. And thank you, Lari and Vesa, for your interesting presentation. And I'm sure that since there were probably a couple of questions that we don't have time to address now, you can contact Lari and Vesa afterwards in case you are interested to hear more about this solution. But next on our program, we have Elina Lohiniva. Elina will be sharing more about the latest sort of information on lignin recovery. Elina is the Business Development Director, Lignin at Andritz Pulp and Paper. She's been leading the lignin business development at Andritz for over 3 years, and Andritz is one of the world's leading technology suppliers for the pulp and paper industry. So please, Elina, the stage is yours.
Okay, you hear me? Yes. Okay, thank you very much. Good morning, good afternoon, and thank you for giving me the opportunity to tell what's new on lignin recovery on Andritz site. Very shortly about Andritz, we are a multi-divisional company working globally in 4 different business areas: pulp and paper, metals, hydropower, and environment and energy. And what we do is we develop large-scale, state-of-the-art engineering and service solutions, as well as of course, the technologies. We are supporting our customers' operations with lifecycle services, and today, more and more empowering our customers to drive the green transition with the e-fuels, carbon capture, and hydrogen, for example. Last 10 years, maybe or more, we have been also in a pulp and paper side looking how we can, together with our customers, unlock the hidden values in their side streams, and of course, accelerating green technology development and creating new revenue streams. And that is that has been done by looking how we can reduce consumptions of water, energy, and chemicals at the pulp mills. How we can reuse side streams as a new resources inside mill. A good example is a sulfuric acid plant for this. And then how we can refine side streams to create new value-added products, and biomethanol and of course lignin are good examples on that development. And then when we go to the recovery area, where lignin is of course a quite important part, as mentioned, we have been doing providing new products to the market. One is our Kraftanol product, where we are purifying raw methanol to commercial quality biomethanol. And then our Sulfaloop product, where we are producing commercially quality concentrated sulfuric acid out of CNCG. And today we have, under Sulfaloop, we have also other means of helping to solve the sodium-sulfur balance. And last but not least is of course our lignin recovery product. Driver for a lignin I see is mainly the resource efficiency of wood. How we can take more out of the wood coming and not burning it, but making a new advanced bioproducts, mainly those which can replace fossil materials to reduce the carbon footprint or resource lack of resources. In Andritz, we are under lignin recovery. We have actually two products. Lignarec is we call purified or standard lignin product, where lignin is recovered first as from the black liquor, and then in the second stage it is purified with acid washing, and the end product is bulk raw material, which will be then further refined to different applications. And this is a technology we are also providing to Södercell Mönsterås project. Ligniox is an alkali oxidation process for lignin solubilization. And Ligniox was invented actually by VTT, Governmental Research Centre of Finland, and the process was further developed in an EU Ligniox project by a consortium of biorefineries, technology providers, chemical industry players, and of course research institutes like VTT. And the VTT has a patent, is a patent owner for the application use, and there's the shared patent for integration of the Ligniox process to the kraft pulp mill by Metsä, Andritz, and VTT. The process is a slightly different. It has a precipitation of lignin with the help of CO2, same as in the we call traditional standard lignin process, Lignarec process. But then we have oxidation and membrane filtration processes afterwards, and the final concentrate is ready for end-use applications, or only some small formulation is needed. The concentrate can be dried if needed for the easier transportation. And after the EU project, Metsä, together with Andritz and Dow Industries, has continued development. And last year, Metsä did an investment decision for the demo plant for the Ligniox, and the demo plant is now actually on construction phase, and will be started up end of this year. And Andritz is a technology provider for that demo plant. A couple of words about lignin products. The development on the product side has been quite intensive, and there has been a lot of different product possibilities, and are still. And I think the development is ongoing. There are already some applications like phenolic resins and on the market, but maybe the lack of production of lignin has been also hindering a little bit the development further, and we are of course very happy that Södra plant will be delivering then rather big amounts of material to the markets. And Ligniox, the oxidized alkaline lignin, is a little bit different applications. In the EU project, the Ligniox product was tested in concrete and gypsum as a plasticizer, and with very good results. Shortly about the process itself, or Lignarec process, we are removing black liquor from the evaporation plant, and we do have a precipitation of lignin with the help of CO2. And then the precipitated lignin is recovered in a filter press, where the cake is further dispersed in an acidic acid filtrate, and the pH is dropped with the help of sulfuric acid. The lean black liquor from the filter press is fed back to the evaporation plant. The acidified slurry is then filtered and washed so that we can get remove of impurities like sodium, and the material can be dried. In most of the cases, it is easier to transport when it is dried, and there we have a flash dryer technology, and then the lignin can be further modified to densified, or what this is the needed way for the customer. The main component of the filter of the Lignarec process is the filter presses. We have our own filter press technology in Andritz, and a lot of references from different industries and different applications, but now also for lignin. When we are talking about lignin recovery, it's of course this what I just showed you, but filter press technology, and then we have a dryer. In most of the cases, we are, because of the rather high explosive characteristics of the kraft acidic lignin, acid purified lignin. In most of the cases, densification, some kind of densification method is good for helping to transport it safely. As mentioned, we are utilizing sulfuric acid in the process for removing the sodium. So in most of the cases, when we are talking about lignin recovery, also sulfur loop solutions we consider to help to reduce the effects of the sodium and sulfur balance of the mill. And CO2 capture today more and more important. We have our own CO2 technologies, amine scrubber and membrane technologies, and today very often discussed when talking about lignin recovery. We can extract the flue CO2 from the lime kiln or recovery boiler flue gases and utilize that in lignin recovery, which would be a quite interesting way. When talking about integrating lignin, mill balance effects to the evaporator and recovery boiler is of course needed to be investigated, as well as sodium sulfur balance. Lignin dry is our lignin drying technology, so it's a flash drying technology. Again, very much used already in the industry, but now also utilized for lignin applications. For sulfur and sodium handling, we have, for the sulfur balance control, there are different means. The WSA plant, which will be also installed in Södercell Mönsterås, is of course one way, and maybe the most common way, so that we take out the CNCGs of the mill and produce sulfuric acid, high concentrated sulfuric acid. And then we have different means like liquor heat treatment and green liquor stripping to increase the sulfur extraction if needed. And lately also a Thiokraft, a bacterial-based solution is come into the product portfolio. And then we can do, we have of course, there are also means to help for the sodium balance control. But suitable technical solutions for each customer need to be evaluated case by case. Then going to the latest references, we were very happy last year. We were awarded 2 projects for Lignin. First of all, we were awarded in April demonstration plant for Ligniox, as discussed, and it will be built to Metsä Fibre Äänekoski mill. And startup of that project will be end of this year. And then, of course, the big one is the Lignarek, Andritz Lignarek lignin plant to Södercell Mönsterås. And in the same project, we are also providing the Sulfaloop sulfuric acid plant and some other smaller process areas. And so that is of course our, we are very happy about that. And the engineering is well ahead, of course. Startup will be 2027. For Sulfaloop, we have, of course, also a couple of sulfuric acid plants already in operation, one in Klabin Ortigueira and one in Suzano's mill in Brazil. This Metsä Äänekoski demo plant is a 2 tons dry solid per day plant and uses softwood and hardwood, and of course the end user will be biodispersants, plasticizers, or various end users. Södercell Mönsterås, I wrote here that it's one of the world's most modern pulp mills because of that it will have all of these side stream products. A Kraftanol plant already started up a couple of years ago, and now there will be lignin recovery, lignin drying, this sulfuric acid plant, and liquor heat treatment to boost sulfur removal, flare, and DNCG handling. So where we are with lignin, Mönsterås will be world's largest lignin plant for kraft lignin, will be started up 2027, and then acid washed kraft lignin material will be available for the market with larger volumes available, and hopefully it will boost end use development further and bring new investments for lignin. Ligniox demo plant startup 2025 end of 2025, and it will be demonstrating the Ligniox technology viability in continuous operation, producing material for the market testings. And of course, then we are also waiting for the full size plant for Ligniox technology to come. With the investments now done, we see the future bright for lignin. Thank you very much.
Excellent. It's quite exciting, Alina. I like what you said about unlocking the hidden value in our products, and you've certainly offered many options and paths forward for that. Let's start with a question, one of our earlier questions. What percentage of lignin what percentage of lignin removal is allowable before it begins to significantly impact the electricity generation system of a kraft pulp mill?
Well, I think it is very much dependent on the mill, the electricity. I think what is the mostly done is look first on the recovery boiler side, that how it affects on the recovery boiler operation, and that is mostly defining the maximum capacity. I think electricity is a little bit case by case, need to be evaluated case by case. It's so much dependent on the mill.
Yeah, that makes sense. A practical question, is there any solution to reducing the smell of the standard lignin?
Well, yeah, there are. I think there are developments ongoing, let's say so.
All right, then. What do you see as the biggest challenge or risk to add lignin recovery to a kraft pulp mill?
Well, I'm a bad. I don't see any risks. Of course, I would be. That is not my
only opportunities, right?
Yeah, only opportunities. Yes. Yeah. As I said, I think the main thing is that need to be evaluated the effects and have a suitable size lignin recovery for that particular mill, and it requires quite good collaboration with the technology provider and the mill, the companies investing.
Is there sort of an ideal mill that Andritz would have in mind as a partner?
No, I think everybody. I think we would like to have many lignin plants in different areas on different geographical. So no.
Okay. All comers welcome. Do you offer a piloting concept similar to Valmet's LignoBoost?
Piloting means we have a portable pilot, which we transfer to the customers to do the testings that we do.
All right. And of course, I feel you'll be glad to answer this question. Would it be possible to get samples of Lignorec and Ligniox?
I need to go back to our customers. I think then I think we like to maybe forward this to customers, but I think for the Ligniox, I think Metsä is the right. You can maybe contact me and I can forward the questions to the right persons.
Okay, great. So they anyone interested in samples should contact you first, and you will connect them with the possibility.
Yeah.
Okay. Here's an interesting question. Given the potential for the production of lignin-based applications, is there a sufficient supply of black liquor that would support the production of bulk amounts?
Well, yes, I think because I think the lignin recovery is quite easily included in many mills, so I think that is not an obstacle, and I think it is more than, there should be more flexibilities, a lot of flexibilities, possibilities.
All right. And you mentioned that the lack of production so far has hindered new markets. But as production ramps up, of the many potential uses, which do you see as likely to grow next?
Maybe Victor is in the next presentation. I can forward it, and maybe he will be better answering that one.
All right.
I think it is, to be seen. Let's see.
To be seen. All right. And Victor, be ready for that. What is the capacity of the portable pilot?
Portable pilot is some, we are talking of some tens of kilos per day.
Okay, per day. Do we have any other questions from our attendees before we move on? Well, Lena,
yes.
I think you. Oh, yes.
No, I was just about to say that. I guess there aren't any. So, and I think given the time schedule, I think it is a good segue from the previous question to move on to our next presentation. So thank you very much for all the questions, and thank you, Elina, for an interesting presentation. And as mentioned, if there are any questions that were left out, or there's something that people have in mind, please contact Elina for more information. And next we'll hear more about the Södras Mönsterås project that was already referenced in Elina's presentation. And we have Victor Odenbrink from Södra to join us to tell more about this. Victor is the sales director at Södra Bioproducts. He has nearly a decade, has been with Södra nearly a decade and 8 years focusing on commercial and business development. And Victor will be sharing more about Södra's project and especially the Mönsterås project. Please go ahead.
Thank you, Vera. And yeah, maybe Andrits and Södra should have done the presentation just like Larry and Vesa together. A lot of common questions. Absolutely. But thank you so much for being here, and a lot of good questions, and good afternoon from Sweden, and good morning for someone. So hopefully I can put the previous presentation a little bit more into perspective from a pulp producer and why lignin at the pulp mill, and a little bit into the market. I cannot deep dive into a lot of deep questions, but I will try my best to answer all the things you answer there. Let's see here if it works out. So good. Let's start with Södra as a company. I think we need to put it into a context. Why Lignin? So we are an old company, founded in 1938, with kind of the idea that we together are stronger. A lot of forest owners here in southern part of Sweden have a lot of forest together, of course. But the demand during this time was not that big for the logs. So our founder Gösta came up with the idea to create an economic association or a cooperative to get a bigger mass, and then set up industries around it. So that's kind of the value and why Södra exists as a company. We should valorize our members' forest and increase the profitability for the forest estate. And we do that through different industries. So turnover-wise, 2.7 billion euros on a yearly basis. Employee base of a bit more than 3,000 employees who should increase the value for our forest owners. And today we have 3 pulp mills, all located in southern part of Sweden. And one on the southwest coast, one on the really southern part of Sweden, and one on the southeast coast, Mönsterås, like Elina showed before. And 7 sawmills. 6 here in Sweden and 1 in Finland. And a couple of years ago, we also invested in a plant on the west coast for cross-laminated timber. So we also have that in our portfolio. So today, a bit more than 50,000 members. Normally say that for those who can see Sweden in front of you, if you draw a line from Stockholm to Oslo, Norway, every second tree south of that line belongs to our members. So Södra doesn't own. We own some small forest, but the majority of the forest is owned by our members, and they are actually not obligated to deliver the raw material to us. But our offer should be the best, so the forest should come into our industries. So this is kind of the products we produce. I mean, paper pulp. We are one of the big actors globally, also on wood products. So we are super big. We also have some production of seedlings that we sell externally to members, but also externally. And on one pulp mill, we also produce dissolving pulp. So that is pulp that goes into the textile value chain for viscose or lyocell production, but also a lot of other applications. So this has been really of the core, and I think a good recipe for Södra historically to really grow in those areas. But during the last couple of years or 5 years, there's been a little bit of a change on the raw material situation, because if you grow in those areas, you need more trees. And many years ago, there was a little bit of a oversupply of raw materials, quite easy to grow by that. But a couple of years ago, and especially since the war, the raw materials, there's been a structural change, you could say. So we see it super important to make more of every tree. So we also produce biochemicals like crude tall oil, turpentine, our biomethanol that was mentioned before. A lot of different biofuels, like the bark that we produce on our industries and sell. Biomethanol can also be included in that one. Biomaterials could be our sawdust, for example, going into different applications, cutter shavings. So many different things there. And Lina mentioned it before also. I mean, if you're going to take out lignin, you need a surplus of energy. So we, of course, produce a lot of electricity from our industries today and sell out on the grid, and also a lot of district heating that we sell to nearby cities. So we are quite of a broad portfolio if you look into the whole company, what we are doing. But like I mentioned, one single tree produces 1,000 of opportunities. So that's what we really try to go for. A lot of base products, but try to be a bit optimistic and try to find new things all the time. And I think the lignin can be one example here, but also the biomethanol, because in the end of the day, our purpose is to increase the profitability for the forest estates, and to be able to do that, we need to make as much as possible from every single tree. So 5 years ago, it was a startup for our biomethanol plant on our Mönsterås pulp mill. So first in the world, being able to use that, utilizing the raw methanol stream on a pulp mill and purify it into a commercial grade methanol. 5 years ago also, we made a press release that we will enable large-scale textile recycling. And what do we mean with that? Yeah, taking in used textiles and use those again. And the best part there is that we can use blended textile that contains both polyester and cotton, which is the most common one. Can put it into our process and separate those fibers from each other and use the cotton fiber again into our dissolving pulp. So this has gained a lot of attraction from a lot of brands, and we call it once more, that we use it once again. And the investment decision we took last year, it was actually two quite close to each other. We went out officially that we will invest in a tannin production on the west coast, our Verimill, a product that can goes into a lot of different applications as well. And of course the kraft lignin that will make Södra to the world's biggest kraft lignin producer. So it's not a project, we call it actually a program, but I will tell you a little bit more about that. So how has this journey been? Yeah, I would say we started lignin for many pulp companies. It's not something new. First of all, I think we started to look into lignin first time 2004 or 2006. So it's always been there. Maybe the market has not been that matured. So before the investment decision, a couple of years before that, we made a press release that we're looking for partners in the field of lignin, called it a bond for the future, a way for us to start to communicating to potential value chains, try to understand different applications. And also have to say that the investment itself has also been got some money from a Swedish authority, support of the investment decision. So it's been a journey, like I said, a lot of external communication regarding the investment. Of course, when we took the investment decision, there was a press release. There's also been press releases regarding sales agreements. So this is one with the UPM and another one with Stora Enso that is official, that they will buy product from us. And of course, the technology supplier, and it showed the pictures before, exactly how the process will look. And also that we will not produce any powder. We will produce a solid product, a granule, and that will be Hosokawa Alpine who delivers that solution that you will see a bit more later on here. So the place where we will invest is in this combinate, you could say, because it's not only a pulp mill. We have the pulp mill over there, but also a sawmill, like you can see on the picture. We have some wind power and actually our own port as well, which is quite unique in this sector, which means that we can get both raw material to both industries over there, but also export product directly from the industries. And Södra as a company, we export roughly 80% of our product is going outside Sweden. So most of the product is being exported. And this is also a campaign mill. The majority of the raw material we use is softwood. So the majority will be a softwood kraft lignin, but we also run campaigns with hardwood. So there will also be some hardwood kraft lignin. And without deep diving into this, I think it was described before. I mean, we will have the extraction, of course. We will have a dryer, our own sulfuric acid production. But the buildings down to the right are you didn't see before. That's the granulation plant. So we will make a granule that reminds quite much of frozen coffee for those who drinks that, as a way to reduce the I would say both production-wise to avoid all the dust. It's very explosive. You need apex, but also from a customer point of view, it's much easier to handle, and you get a better density on the product as well. And of course, some flexibility when it comes to the delivery form, you could say. And in this particular case, like mentioned before as well, I mean, you need a huge surplus of energy, because if you take out lignin, you still want to run the pulp mill and the recovery boiler. But in this case, we can take out this amount of lignin without buying any energy externally. We are still self-sufficient on energy. So it's a big program, as we call it, because all of those kind of, in the bottom here, you can see lignin extraction. That is a huge project itself. Sulfuric acid, a big project. Granulation, the same. So this kind of lignin program contains of a lot of different big projects. So to be able to coordinate it in a good way, we call it a program, because this is also a new product for Södra, which means you also need to include the commercial aspects of this, of course, to be able to sell a product that is appreciated by the market. So this is our way of handling it, and then of course through a lot of different steering groups. So what we do is that we go from the black liquor to this wet cake, dry it up to a powder, and then compact it into those granules that you can see on the picture there. And I cannot disclose, I mean, our specific properties of our product, but more talking from a general perspective, because Södra as a company, normally we act quite much as a raw material supplier. If you take the pulp, for example, we do not have any integrated paper machines. We produce the pulp and sell it to someone who use it as it is, or valorize it in different ways, and quite the same on the lignin. We will produce a standard kraft lignin and sell it to someone who use it as it is, or valorize it in different ways. So that's what we will do with this plant. And what is really driving this kind of investment, talked a little bit about it before, but of course the green transition. If you just make some quick calculations regarding crude oil, how much carbon dioxide you release to the air with 1 ton of that, and also look into the EU and US and all the kind of targets that we have. If we should halve our emissions, you need a lot of crude oil. You need to substitute a lot of crude oil. So of course the market can be huge. So this is also driving this, and of course the whole value chains, the brands that connects to science-based targets, for example. There needs to be a solution to be able to make this transition, and we ourselves there, we should halve our emissions until 2030, being net zero 2040, and many other companies and brands have the same. So this is one way to solve that in different value chains. And you also showed this kind of application space before, and I think during the last couple of years, many of those bubbles are new, and let's see where we are in 2 or 3 years. There might be another 3 or 5 of those bubbles, but of course resins is the most major one, where kraft lignin has been used for a long time. But we can also see that asphalt, roofing, biostimulants, rubber, the plastic sector, there will be big markets in the future. So yeah, the project is going very well. So Q2 2027 is the startup, so that we really look forward to start up this huge plant. Thank you. I think that was everything.
Excellent. You say 1,000 products from a single tree. Well, I can tell that Södra is quite excited about the potential of lignin markets. Victor, thank you for that presentation. So that leads me to a question that I wanted to ask, that actually an attendee has asked, and that is, what lignin end-use applications are most interesting to you and have the best potential, in your opinion, to become a large-scale business?
Yeah. I would say we did not really kind of choose in that way. Of course, you need to understand your properties of your own lignin, because depending on what kind of technology you have and raw material, you get different properties of the lignin. So for our case, there are different applications that are really of interest. And of course, if you can find those value chain where the lignin can also make a technical advantage towards the thing that it substitutes, then it's super. Then you have a lot of things. Technical properties gets better. You have the carbon footprint. So finding those applications is what you want to do.
Yeah, that multiple benefit.
Yeah.
Besides lignin-related activities, Södra recently announced that it will invest in another phenolic compound, which is tannin. Could you please elaborate a bit on the possible applications there?
Yeah, I mean, lignin and tannin in combination can be super in a resin formulation, for example. It's more active compared to a lignin molecule that is rather big. So in those kind of application, tannin itself has antioxidant properties, of course, so different value chains there. Of course, into the leather sector where you use tannin for tanning. So that is a common value chain, and also into different kinds of could be different kinds of wastewater treatment where you can use tannin for their properties. So there are many different tracks there as well.
Excellent. Well, back to lignin, what is the application of lignin granules, and does that affect lignin solubility?
Yeah, of course, the bigger it is. But no, I wouldn't say that. It's always a trade-off because at the same time, when you make a granule, you can choose a little bit how hard you want to do it. No, I wouldn't say that. It's not been a hiccup anywhere. Rather good, because it's much easier to handle for everyone.
So you mentioned textile recycling and textile production. That's very consumer-facing product. Do you think that will help expand markets in general for side streams like lignin?
That's is close to the consumer, or what do you mean?
Well, yeah, many of the products that we're talking about are sort of an industrial use, right? So they're not very consumer facing. So it feels almost like some of this work is being done in the dark, right? And for our industry's sustainability profile, do you feel that this type of consumer-facing product or capability helps improve our industry's environmental profile overall with consumers?
Yeah, in general, I mean, that's what we are doing. We are substitute a lot of different fossil sources. So first of all, but in general, I think kind of the whole sector or the whole value chain can be better on telling the story of what we actually are doing. Yeah,
that's exciting.
Yeah.
Here's a question. You've secured various contracts to supply the lignin. Is there still availability to an open market as well?
Yeah, it is. So if you're interested, just reach out. I will answer.
I think Alina mentioned that as well.
Yeah.
We have another question here regarding the odor of lignin. It says in some of the applications you mentioned it plays quite an important role. Are there ways you're addressing that?
No, I would say, like I said, in this case, we will go for a standard craft lignin, but of course we are aware of that. There are add-ons today, and there will be different add-ons to later on as well. So we have also tried to be a bit flexible, so we can adapt to potential future requirements as well.
Okay, excellent. I think we've addressed all of our, I'm checking our chat here to see if there are any questions specifically that I've missed. A lot of interest in what the future markets will be, really, which you've addressed. Yeah, excellent.
Great.
Super.
So thank you very much for the presentation and for the excellent questions. So we live in kind of exciting times, and we can't wait for 2027, and of course before that with the exciting other innovations that are coming up. To kind of conclude our webinar, we have Chris Lignin, professor at Georgia Institute of Technology. Chris holds a PhD in pulp and paper science, surface chemistry, and brings his extensive experience from both academia and industry, with expertise especially in quality management, consumer products, and pulp and paper innovation. And Chris will be sharing the closing remarks and his views and kind of insights from the research perspective, and insights from the US side of kind of geographically from the US side. So please, Chris.
Can you see my full screen?
Yes, we do.
Yeah, excellent. So I going to give that, thank you for the introduction, and thank you for all these other speakers today. They were outstanding and very informative. I'm taking a little bit of tack here of talking about what the U.S. Academic work is going on to create more value from lignin. Let me see here. So some candidates for biorefining of lignin. Certainly, we burn a lot of it right now for various uses of steam. 65 million tons is currently burned. But we think that there is some other options in the future for using of lignin. And the biggest question is, what are the value categories that could be used if we could effectively and economically break down the lignin molecule instead of using it in its bulk form, such as in resins, which is an economic way to do things, but actually to create more value. The biggest challenges, of course, is it's a very complex aromatic structure, has a high degree of variability depending on its source and species of wood, and it's a very reactive material. So the macromolecule, current commercial applications, we've talked a lot about today of dispersants, emulsifiers, binders. These tend to be very low value and limited growth categories for most markets, but opportunity areas such as carbon fiber, polymer modifiers, adhesives, and resins, and even beyond. And we'll talk a little bit about some of the current research going on in that area. This is some work by Dr. Satish Kumar in our School of Material Science around replacing PAN as a precursor for carbon fiber synthesis. This is his published work in a number of peer-reviewed articles of melt spinning followed by pyrolysis to make carbon fiber. The other thing that is obvious when you look at the lignin molecule is that you could potentially get a lot of value-added chemicals from it, such as the phenol, the benzene, toluene, and the xylene. And this is from the Department of Energy way back in 2007. If you think about what we could get out of lignin, if we could make benzene, xylene, toluene, butanes, the number of value-added products that could replace petrochemicals is enormous, just from the lignin molecule. But that is the biggest challenge, correct? If you think about these kinds of things that we could make, polystyrene, nylon, and there are some faculty that are working in this area in the US, and I'm sure around the world, on trying to get value-added chemicals from the lignin molecule. This from the 2016 RISI report just describes the potential market volume of various forms of lignin going into a potential market, and all the way to phenol derivatives, vanillin, of course, some people making synthetic vanillin, carbon fibers, and the lowest market volume production would be around energy or this is actually from left to right, the highest. I want to talk a little bit about a center, an engineering and research center that we formed at Georgia Tech called REWOOD, and what that is trying to work on. Just don't want to go through this entire mission here, but this is a center for renewable chemicals from wood, and our mission is really looking at waste products like the lignin molecule, but also waste wood, and forming value-added products from the waste materials. If you look at petrochemistry as opposed to what we've referred to as xylochemistry, of replacing petrochemicals in a number of applications, much more sustainable and abundant. We often talk about the most prevalent polymer on the face of the earth is cellulose, and the second most being lignin. We have a lot to potentially make from it. And so this xylochemistry is really all about taking the wood as a raw material and looking at conceptually an approach to sustainable chemical economy. It's a well-suited, valuable, basic chemical for utilization for a number of different applications. And we'll talk a little bit about pharmaceuticals in particular, but also some work in fuels. So the U.S. forest resources are rather enormous, particularly in the Pacific Northwest and the southeast of the United States. The rank among southeastern states is right here, number one being Georgia, where I'm located, but also Alabama, Mississippi, North Carolina, South Carolina. There's a lot of underutilization of forest land. About 50% of Georgia's forest goes into pulp, and the rest is into plywood and MDF and other forms of construction products. A lot of sawmills in the southeast. And the DOE and USDA believe that we have 1 billion tons of biomass availability sustainably, and 200 million of that tons would be forest biomass. And this would be a potential increase in our chemical industry if we could source materials from the wood. So this REWOOD Center is focused on these 4 areas. There is a professor and a team working on a replacement for nylon called Xylon. We're working on fuels such as sustainable aviation and shipping fuels from southern pine being particularly well suited for that. The bottom right around fertilizers and agriculture, very high carbon footprint of biochar and lignocellulose can be converted to fertilizers and pesticides alternatives. And the upper right around pharma, and this in particular is the replacing of fossil fuel-based precursors that go into many of our pharmaceuticals. Just the value tree here of what could be coming from lignin and the number of molecules that you could potentially get from a tree, just as an example of various things that you could potentially get. The team at REWOOD is made up of these primary investigators, particularly Bo Arduengo from School of Chemistry, Andy Bamarius from Chemical Engineering, Stefan France from Chemistry, myself, Dr. Meredith, the head of the Renewable Bioproducts Institute, and Dr. Thomas, who's an excellent resource around life cycle assessments and techno-economic analyses. I want to point to a particular product that has been recently done, awarded PhD, Dr. Jimin Park, who worked for Dr. Andy Bamarius's team around green, renewable, and continuous manufacturing of the active pharmaceutical ingredient paracetamol. And to see the number of publications that Jimin was able to do. The idea here is that paracetamol, a precursor to making acetaminophen for Tylenol, is currently sourced rather economically from the petrochemical industry. But this thesis work and much support work that has been done over the last couple of years has shown that the phenolic material from lignin could easily be the precursor instead, and that we could source our Tylenol instead from trees. That is an example of some of the things that we're working on here at Georgia Tech. And there is work, of course, going on at a number of institutions. We collaborate with some of the other pulp and paper schools in the United States. There are 10, after all. Georgia Tech here is just one of them. But there's a tremendous amount of work going on. And the key question that we often ask ourselves is, can you create money from lignin? We burn a lot of it, and we do have value from that. But there is so much more that we could do. And membrane technology to separate by molecular weight, we believe, is one avenue for that. Breaking down lignin into its monomers is another avenue that much of the work going on in other professors' work in metal catalysis, for instance, is working in this area. So there's a tremendous amount of work, and I have great hope that in the next decade or so, we will crack the question of, can you make money from lignin other than the bulk lignin itself? So I'd be open to questions.
Thank you so much, Chris. I love the term xylochemistry. I had not heard that before, and I think that's precisely the kind of language that helps us talk about the potential, right? Thank you also for mentioning the interesting opportunities in pharmaceuticals when we talk about sustainability. And I certainly think that that sort of green focus for pharmaceuticals is quite interesting. I have to ask, as someone from North America like you, in our presentation so far, we've seen several pending projects around the world, but none in North America yet. So where do you see the biggest challenge for North America in reaching the level of market readiness that has been achieved in Europe?
Well, there are people making lignin and selling it in the United States. The one example, of course, is Domtar, using Metsa's patented LignoBoost technology. The biggest challenge, however, is using it as a filler, using it as a material that may have equal or not much more value than the value we get from burning it as a steam source. The key question has often been, what is it being used for? Well, lignin is being used as a filler in adhesives, material in resins. There are people experimenting, of course, with making injection molded parts with lignin. When you ask the people what is actually lignin going into, particularly from craft lignin, it has been experimented with as a feedstock for cattle. There are people touting its antibacterial capabilities. There is, of course, people putting it in as a resin. We've experimented with injection molding ourselves for flatware as an inexpensive thing to add to things like polylactic acid, which is expensive, versus polypropylene for flatware. So there are people that are doing this. The true value that we think from lignin is breaking it down into its parts. There are certainly people that are going to be able to market lignin as in its bulk form, whether sulfonated or not sulfonated. There's people that are making non-sulfonated lignin and experimenting with it as well here in Georgia. And so the real value, where you got into higher value added products, I think is where we have the potential of making more value from our lignin molecule.
Yeah, that's quite interesting. A question that had been asked for Alina, which we was asked a bit too late to answer directly, but I think it applies to everyone really. And you've just been referring to it, Chris. So the fact that we burn a lot of lignin right now, and there are other filler uses, the question posed by the attendee is, how do you consider the environmental trade-off between an extended lignin market and the resulting diminished supply of renewable power for the kraft mill?
May I just talk a little bit about this? I know others may have.
Yeah, no, absolutely. It's
going on.
It's
but
directed to you, Chris.
Yeah, I think right now the U.S. pulp mills are looking at it as a way of debottlenecking for more production. So you certainly get a lot of value from burning lignin and creating steam. And in some cases, there are very highly efficient mills that are able to use that steam to run turbines and contribute to the electric grid. Other mills are not as efficient. But if you're trying to make more pulp and you're maybe recovery boiler limited, which many cases older mills are, they may be derated and you're not able to make as much pulp production. If your recovery boiler is your bottleneck, then marketing of lignin may be an outlet. You still have to somehow recover the sodium to make new caustic, but it is an outlet for some people to think about, is marketing their lignin and debottlenecking to make more pulp production for a particular mill. I think that this is the case for particularly some of the older and longer in the tooth mills here in the Southeast that were built in the 60s and 70s, and so they're examining that.
Excellent. It's an excellent point. Here's a practical question. What is the kappa number of the pulp where part of this black liquor will be used into the lignin plant?
Well, anybody can chime in here. I think that the kappa number of the pulp could vary quite substantially. We have some linerboard mills that are pushing the kappa number above 110, 120 these days. That lignin certainly is still a viable craft lignin. The bleached mills are going to have some lignins that are kappa numbers down in the 20s. There's fluff pulp mills that have even in that tens or teens kappa number. So I think depending on what it is you want to do with the lignin, you can extract it from the black liquor before it gets concentrated, and you can do that at any of these mills.
And I think I can also add some answer on the last question, because I think that's an interesting one. When you kind of taking out lignin, of course, you put the carbon into a product and you make a substitution for something else. Of course, that is something that we have looked at very much. And I also like you say, Chris, there, that often it's kind of the recovery boiler that is also limited from a general perspective. So if you go into the production and try to find ways of reducing the energy, you never get kind of the output from that because you are full in the recovery boiler. If you take out lignin and start saving energy again towards the whole process, you can start gain money from that one. So I would turn it a little bit around, it also creates opportunities, of course, to start saving energy in the pulp.
Thank you, Victor. Are we ready to open to more general questions? I believe I've got all of the questions specifically for Chris. Do we have time for that, Vera?
I think we need to start wrapping things up in case there aren't any other questions in the chat that we need to address, so we should address. Okay. Yeah. Thank you so much for all our speakers, and thank you, Jan, for co-hosting and moderating the Q&A. Thank you to everybody who joined today. It was a very interesting and very concrete examples and great discussion and great questions from the audience. As it was I mentioned in the beginning, this webinar was recorded, and within the next couple of days, you should be able to find it at ForestBioFacts learning environment and also at TAPPI's website. So you can revisit the webinar or share the recording with anybody who is interested in the topic. Within the next couple of minutes, or you already probably received it in your emails, there should be a feedback questionnaire or link to a feedback questionnaire. So we would appreciate if you spare a few minutes to provide us with your thoughts about this webinar, and also give us some suggestions or wishes or thoughts about upcoming webinars or topics or subjects that you would like us to address in the future. The ForestBioFacts webinar series will continue in the fall, but I also encourage you to check out TAPPI's website. There are a lot of interesting webinars and events coming up, so make sure to check that as well. But yeah, thank you everyone for joining. Thank you our speakers, and I wish you a very nice rest of the day.
Thank you for attending our event. ForestBioFacts helps you to find everything you need to know about forest-based products and technology. Hopefully, you'll take the most out of this digital learning environment. You can see all upcoming ForestBioFacts events, such as webinars and their themes, on our website. Thank you, and welcome again.